Alright, in this lesson we will practice graphing both square root functions and cube root functions. And we will also explore how to graph more complex functions when you have a horizontal stretch or compression. See the number here in front of the parentheses? We haven't worked with those before, so we're going to see how to graph those as well. It's a little bit more complicated. Alright, problem number 1. As soon as I see the A value right here, this 2 is the A value, I know I'm going to need a 3-column table of values. Alright, so I will definitely use a 3-column table. So this is the square root function, so that lets me know that we will use the same values that we always use, 0, 1, 4, and 9. Because those are the values that we can easily take the square root of. Speaking of which, in the middle column we will go ahead and take the square root of these, the parent function. So that's 0, 1, 2, and 3. But before we graph anything, we will go ahead and apply the A value. Alright, now the A value is 2. So that means I'm going to do 2 times the square root of x. Alright, see how I put AY here? That's to remind us that we're going to multiply the A value times the Y values. So 2 times 0, 2 times 1, etc. So 2 times 0 is 0, 2 times 1 is 2, 2 times 2 is 4, and 2 times 3 is 6. Alright, once we have that third column, we can forget about this one. We will use these Y values instead. Now, when I plot these, this will not be my final answer because we still have to shift. But let's see. We'll make our skeleton 0, 0, 1, 2, 4, 4. Alright, I guess for today, because they're giving us this tiny graph, we'll just stick to these 3 points. But if they give us a bigger graph, then we'll use the 4th point. Now this function has 3 transformations corresponding to each one of these 3 numbers. The 2 in the front is a vertical stretch by a factor of 2. And then the negative 2 will send us to the right 2, and the positive 3 will be up 3. So right 2, up 3. So we can take this skeleton of that we just graphed and shift each point right 2 and up 3. So if I do that, this will go right 2 and up 3 will be here, and another right 2 up 3, and another right 2 up 3. So this will be my final answer. Alright, so that is it for, well, no, I guess that's not it. That's the graph for problem number 1. But now we have all these other interesting questions that we're supposed to answer. For example, the starting point. This has a starting point of 2, 3. Alright, so we'll put that. 2, 3. Is this increasing or decreasing? Alright, well, we always read it from left to right, so this is increasing. The domain. The domain is from left to right, so the x values go from 2 to positive infinity. The range. The y values go from 3 to infinity, bottom to top. Absolute maximum or absolute minimum. There is no absolute maximum, okay, because it goes up forever. The absolute minimum is here, is 3, right? That's the lowest y value. So the absolute minimum is 3. When you do absolute minimum and absolute maximum, technically we're talking about y values, unless I say where is it. Okay, what else? Oh yeah, end behavior. As x approaches, now normally we say negative infinity, but this graph stops right here. So it doesn't approach negative infinity. The x values approach 2, because that's where the end point is. So as x approaches 2, okay, the function approaches, and basically this is like saying the y values. Okay, so as we go to the left, we're approaching this point right here. So as the x value approaches 2, the y value approaches 3. See it? It's right there. So that's basically what we're saying. Now, as we go to the right, the x values go to infinity now, because it goes to the right forever. And the y values also go to infinity, because it goes up, 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 up. So that's the end behavior. And now that really is it for problem number 1. Hey guys, that's going to do it for this video. Go ahead and click over here to watch the next video, and click over here to subscribe. That way you'll get every new video delivered right to your home screen.